So in this video, we are going to discuss about the condition for reciprocity and symmetry for Z parameter. So first, let us discuss about reciprocity, and then we go for symmetry. Okay, which we know that what is reciprocity. So if I connect the input at one terminal, input voltage at one terminal, and I'm going to measure the current at the output terminal. Okay, so I'm going to replace this, that is interchange this V and I. Okay, so if I connect instead of voltage, I'm going to connect current, and instead of current terminal, I'm going to connect a voltage. So before this one, I'm going to write the two-port network for Z parameter, that is equal to V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. So there is a mistake. So this is how you have to draw the two-port network diagram. Okay, you can see the I1 and I2 through the arrow mark. So to find reciprocity, so step one, what I'm going to do is you have to get the expression. Okay, that is ratio of output by input. That is, output is here is a response, and the input is excitation. Okay, so the response is I2, and excitation is V1. Okay. So in terms of Z parameter, so first let us draw the circuit diagram. First I'm going to connect V1. Okay, so this is a two-port network. This is how the two-port network this I2. So since I2 is in the opposite direction, so I'm going to write it as minus I2. So since output is short circuited, V2 value is 0. Okay, so you substitute in the above two equation. So you can see in this V1 is equal to Z11 I1 minus Z12 I2, because here I2 is minus I2. So V2 is 0, so Z21 I1 minus Z22 I2. Okay, so I need to get the expression in terms of I2 by V1. So from this equation, from 3, I can write Z21 I1 is equal to Z22 I2. So Z1 is equal to Z22 I2 divided by Z21. So this is my fourth equation. Substitute this fourth equation in second equation. So if I substitute the 4 in 2, I will get V1 is equal to Z11 into Z22 I2 divided by Z21 minus Z12 I2. Okay, so what is so this is V1. Okay, so I2 by V1. So here you can see del Z. Del Z is equal to Z11 Z22 minus Z12 into Z22. So that is your del Z. Okay, so V1 is equal to I1 into I2 into del Z. Okay, so so here V1 is equal to I2 into Z11 Z22 divided by Z21 minus Z12. Okay, so what does I2 by V1? I2 by V1 is equal to Z21 divided by del Z. Okay. So the next step is we need to interchange the voltage and capacitor. So here V2 and I1 are 2%. So here V1, V2 is by excitation, that is input, and I1 is by response. So we need to find the value of I1 by V2. So if that is the case, I have to redraw the diagram by shorting the value of V1, right? So the step 2 is we will get the expression for the ratio of the response I1 to the excitation V2 in terms of Z parameter. Okay, so I'm going to interchange the I and V. So this is how the network look like, right? So here it is minus I. So I substitute in the first and the second equation. So if I substitute in the first and the second equation, 0 is equal to Z11 I1, right? So it is minus I1 plus Z1 to I2. So V2 is equal to minus Z21 I1 plus Z22 I2. So from this equation, I can write Z11 I1 is equal to Z12 I2. Okay, so what is I2? I2 is equal to Z11 I1 divided by Z12. So you substitute this 7th equation in the 8th equation. So V2 now it becomes equal to minus Z21 I1 plus Z22 Z11 I1 divided by Z12. Okay, take I1 common. So if we take I1 common, you will get minus Z21 Z12 plus Z22 Z11 divided by Z12. So this is nothing but del Z, right? The numerator is term is del Z. So in order to the condition for symmetry is V1 by I1 is equal to V2 by I2. Okay, that is V1 is equal to V2 and I1 is equal to I2. Okay, so you take these two equations from the step 1 and the step 2. You take both equation. Okay, so this is your 9th equation and this is your 10th equation. Okay, So what is Z1 1, Z1 2, and Z2 1 and Z2 2? That is equal to Z1 1 my Z2 2 minus Z1 2 Z2 1. So the second write it as del Z. Okay. So from the equation 10 and 9, I can write. I'm going to compare these two equations. Okay, 9 and 10. So V1 is equal to V2 and I1 is equal to I2. There is a condition for the symmetry. Okay. So you substitute any these two values in 9 and 10. Okay. V1 is equal to I1, I2 and 2 del Z divided by Z21. This is your 10th equation. And what is V2 from the 9th equation? V2 I1 del Z divided by Z21. So Z1 2. So here since V1 and V2 are the same, so both get cancelled out, and I1 and I2 also cancelled out, and del Z and del Z also cancelled out. So you get 1 is equal to Z1 2 divided by Z2 1. So that is equal to Z1 2 is equal to Z2 1. So this is a condition for reciprocity. So next we will go for how to find it for symmetry. Okay, so the condition for symmetry is there is also V1 must be equal to V2 and I1 also equal to I2. Okay, so we need to find the value of input impedance and output impedance. Okay. So what is input impedance? Input impedance is nothing but V1 by I1 and output impedance is V2 by 8. Right. So we know that the equation for Z parameter, this is a equation, and you have two equations, right? So this is the equation. So here you can see V1 by I1 is equal to Z1, right? And V2 by I2 is equal to Z2. Okay, so now you can equate these two equations. So if you equate these two equations, you will get the answer as Z1 is equal to Z2. So that is a condition for the symmetry. So first you have to write the equation, then you have to get the expression for the that is related to input and output port. So first input port is V1 and I1 and output port is V2 and I2. Okay, so to get the input impedance, input port impedance, I have to substitute I2 is equal to 0. So V1 is equal to Z1 and I1. Then this is the input port impedance, and to get the output port impedance. V2 is equal to Z2 to I2. For I1 is equal to 0. So you divide these two terms, right? These two equations, that is V1 by V2. So what is V1 by V2? So this is a condition for symmetry, right? V2 is equal to V1 and I1 is equal to I2. This is a condition for symmetry. So V1 V2 is equal to Z11 I1 by Z2 to I2. So here these two get cancelled out. So we'll get Z11 is equal to Z2. This is a condition for symmetry. In terms of Z parameter. So V1 by I1 is equal to V2 by I2. This is also an important equation. Okay, so I can write V1 by I2 is equal to V2 I1.